All right, the last part of this simplifying radicals is when we are working with a cube root instead of a square root. So remember, before, when we were doing square roots, we often didn't write what our index was. When it wasn't written, we just needed to understand that there was a hidden 2 there. When I was doing a square root, I needed a perfect square, which means I needed a number times itself. I needed 2 of them in order for them to come out. Now we are working with a cube root, where our index is instead 3. That's telling us we're looking for a 3 of a kind, or 3 of the same number, to be able to come out. So a number times itself 3 times is what will come out of our cube root. We're going to go through the same process, but instead of looking for the 2's, instead of looking for our pairs, we're instead looking for 3's. We're looking for 3 of a kind to come out. So I'm going to start off by breaking down my coefficient. 54 I know is an even number, so I'm going to divide that by 2, and that gives me 2 times 27. 27 I know is 3 times 9, but 9 I can break down even farther, and notice I have a 3 of a kind. They're going to come out. Don't forget, I also have this coefficient I'm going to have to keep track of. Now x to the 5th is next. Notice that would give me 5 x's. There's a pair of 3 or a group of 3 there. That group of 3 is going to come out, but these 2 x's are left over and they're going to remain inside. Y to the 9th, again, I don't want to do out 9 y's, so what if instead I do y to the 3rd times y to the 3rd times y to the 3rd? Again, our rules of exponents tells us 3 plus 3 plus 3 gives me 9, so I know I can write these because they would be equivalent to one another. That also gives me a 3 of a kind, and my 3 of a kind gets to come out of my radical. So if we keep track of what we have left over in and what we have out, 2 times 3 is 6 outside, and an x and a y cubed. Left inside is this 2 inside of my radical, and these 2 x's, which I would write as x squared. That is what's left inside of my radical. And then just making a quick note like we did before over here, if I take 5 and I divide by its index, 5 divided by 3 would give me 1 2/3. Notice we had 1x come out, 2 remain inside. And if I take 9 and divide by the index of 3, I get 3, which gave us the 3 outside. That is going to come in play as we keep working through these radicals.